Hi friends, my name is Karthik and you are watching Technical Q. So today we will be seeing how to implement 8-bit universal shift register with the help of behavioral modeling style. So you know what is a shift register? Shift register is a combination of flip-flops and each flip-flop stores a single bit. So flip-flop is a single bit memory cell. Okay, so consider this is a universal shift register which does the operation of all the four modes of shift register, that is serial in, serial out, parallel in, parallel out, serial in, parallel out, parallel in, serial out. Okay, these are the four modes. So this USR will have two inputs actually which contain data, that is serial in, parallel in. Parallel in means it contains 8 bits of data, and reset is used to reset the output, that is S out and P out, to 0. And you know what is the operation of shift register? Suppose this temporary variable has this data 10110010. So as our shift register is the positive edge triggered, at the positive edge of the clock, this consider the serial input parallel output mode. Our serial input is 1. Consider our serial input is 1. So after this positive clock, this 7 up, this 0 to 7 data is shifted to right side. So the data at 0 position will be gone from the memory, and the data which is in sin will be loaded in 7th position in temp. Okay, so this is the serial in parallel mode. So your parallel output will be data inside this temp after the clock. Okay, so this 11011001 will be your parallel output. So let's see how to implement this system using Xilinx. Okay, I have written the code already. So I have taken the entity name as shift. You can take as USR as you are implementing universal shift register. That doesn't really matter. So our system will require a clock. So inputs to system will be clock, reset, serial in, parallel in. Parallel in will be 7 down to 0 because it is 8-bit parallel input. And to select mode, I have taken 2 bits, that is mode 1 down to 0. Okay, and type is standard underscore logic underscore vector. So this will select one of the modes from four modes: CISO, CIPO, PISO, PIPO. Okay, and your output is serial output and parallel output. Parallel output is 8-bit, as I told in the diagram. Okay, so to, as I have mentioned in the diagram, to hold my parallel output which is 8-bit and to shift them by 1 bit, I am using temporarily a temp variable. Okay, so I have to create a temp variable, but as I'm you can create a signal also. Okay, I have created a signal here which acts as a variable itself. Okay, so to hold my parallel output temporarily, I have created a temp signal, and I'll tell you why I have taken this count signal afterwards. Okay, in the tutorial. And so our process will include sensitivity list. This sensitivity list includes the inputs which will force your output to change are listed in your sensitivity list. Okay, so I am beginning now. So as I have told, if my reset signal is 1, then my serial output will be 0 and my parallel output will be 0, and I will be loading 0 in my temp register. Okay, so if my reset is not 0, then else if condition will be checked, and in else if I am checking whether my clock is 0. Okay, so as we are implementing positive edge triggered, I will be writing 1 here. Okay, so it will check positive edge of clock. If positive edge of clock appears, then what? Then I am checking which mode I am using. Okay, so case mode is, I am checking my mode. If my mode bits are 00, when 00, then what? Then I am shifting my data which is on 7 down to 0. Okay, 7 down to 1, sorry, and I am loading it on 6 down to 0. So what this statement will do, let's look at the diagram. Okay, 7 down to 1 means what? This part which you are looking at. Okay, this part, 7 6 5 4 3 2 1, up to this part whichever bits are there, you are shifting it on 6 down to 0. Okay, these 7 bits will be shifted on 6 down to 0. So as you can see, after clock, this 1 at 7 position will be appear on 6 position, and 0 will appear on fifth position. So every bit from 7 down to 1 is shifted by one position to 6 down to 0. Okay. So basically that statement shifts entire data one bit to the right side. Okay. So this is serial in serial output mode. Okay. So afterwards, look at the diagram. After shifting, we load the serial input into 7th position as it is empty after shifting by one bit. Okay. So my serial output will be 0th position output. Okay, this is serial input parallel output mode. If I am using serial input serial out, so the data which is on temp 0 position, okay, that will be my output. So I am loading S out with data at temp 0 position. Okay, this is serial input serial output mode. When my mode bits are 0 1, same this statement which is used for one bit shift to right side. Okay, GST side. Okay, so this will shift by your data by one bit which is in temporary signal, and then I'm loading my serial input as it is a serial input mode parallel output, and entire data which is in temp I'm taking it in p out variable. So this is the parallel output variable. Okay, so this is serial input parallel output. In parallel input parallel output, you can directly give your parallel input to your parallel output. Else you can give like you can give parallel input to temp and you can give temp to your parallel output variable. Okay, and this is the third mode, and last mode is parallel input serial output mode. In this mode, when your mode bits are 1 1, you are using this mode. So as I have mentioned, I have taken one count signal which is integer. Okay, so to use this I am deciding the range of this integer variable or signal, that is 0 to 7. Okay, so this signal will have only value from 0 to 7, it will not go to 8 or 9. Okay, I am initializing this variable with 0. So to initialize the signal we use this sign colon equal to. Okay, why I am taking it? If my count is 0, which will be 0 after the first clock because I have initialized count with 0. Okay, so first clock appears, then my parallel input will be loaded in temp variable. Okay, so I have loaded my data into temp, and my serial output will be temp 0 position. As I have told you, 0th position of temp will be my serial output. So I have taken serial output and I have incremented count by 1 so that this condition will not be executed again, because if I have not included this condition, every time parallel input will be loaded in temp and every time you will get same 0th position output, so which will be same bit. Okay, so as the name suggests, it is shift register. You have to shift the bits to right after every clock. Okay, after first clock we have taken the 0th position as output. So now in next clock this condition will not be executed, so it will go to this condition because your count will be 1 at that time. So it is less than 7, then you know this statement will shift your data to right by one bit. Okay, and I'm taking again 0th position as my serial output and I'm incrementing my count. Okay, so this will increment your count. After your count is 7, then this count less than 7 condition will be false, so my temp 7 is remaining to be outputted on S out. Okay, every bit will be given to S out after every clock, so this bit will be remaining because this condition will be false when my 7th bit comes. Okay, so I'm giving S out my 7th bit. So this completes your parallel input serial output mode. Okay, and my mode is when others I am doing nothing. So you have to write here null. Okay, so this is end case which is used for mode. This is end if which is used for reset, and I am ending my process and I am ending my architecture. Okay, we'll see the test how to write a test bench for this universal shift register and verify these modes, and I'll explain these modes in during test bench also. So hope you like the video, and please like the video, share the video and comment down below. Subscribe to my channel Technical.